Hi everyone. Today we're going to be looking at how to analyze the sign of a second degree polynomial. As you will see, it is very similar in procedure to how we analyze the sign of a first degree polynomial, which we did in the previous section under this same heading. So, in your notebook, please put down the heading for today, which is analyzing the sign of a second degree polynomial. Alright, well, I think the easiest way to show you the behavior of a second degree polynomial is to get right into it with an example. So I would like you to put example, and suppose I ask you this. Given a polynomial, let's call it p of x, and let's make it x squared minus 8x plus 7. The question is this: for what values of x will this polynomial be negative, positive, or 0? Alright, as I did with analyzing the sign of a first degree polynomial, let's plug in some random values of x and see what happens. Let's start all the way at when x equals 0. So calculate value of p when x is 0. Well, let's plug it in. 0 squared minus 8 times 0 plus 7, if you did it correctly, should give you 7. Okay, so far so good. Let's keep going. How about we calculate the value of p when x is 1? Alright, let's see what happens. 1 squared minus 8 times 1 plus 7, and that gives 0. Ah, interesting. If we recall from the previous section, we called that this particular value of x is known as the 0 of the polynomial. Or, as some of you may call it, the x-intercept of the polynomial. Alright, let's keep going. Let's try plugging in when x is 2. So, if you calculated correctly, you should have gotten a value of negative 5. Interesting. It starts being negative. Let's keep going. How about we calculate the value of the polynomial when x is 3? If you did everything correctly, you should have gotten the value of minus 8. Interesting, still negative. Let's keep going. But let's jump all the way to plugging in x equal to 6. So what is the value when x is 6? Let's take a look. If you did it correctly, you should have gotten that it equals minus 5. Interesting, still negative. Alright, let's keep going. How about we calculate the value of p when x is 7? If you did it correctly, you should have gotten 0. Very interesting. This polynomial has two x-intercepts. The previous one, which occurred when x is 1, and this one, which occurred when x is 7. Interesting. Alright, let's see what happens after this. Let's plug in when x is 8. If you did it correctly, you should have gotten a y value of 7. It starts being positive again. Very interesting. Let's mark down some of these observations in our red color, please. Well, let's go back to the beginning. When x was 0, this gave us a positive result. Look at what happens between the two zeros. The results were all negative. Isn't that fascinating? And look at what happens beyond the second zero. It starts being positive again. Very interesting. Well, at least to me, it's interesting. So, how do we state this as our conclusion? It's very easy. We state it with a number line. So our conclusion is the following. Conclusion. So the sign of this polynomial p of x is the following. So we draw a number line like usual. Not very long. And on this number line, the first thing to mark down are the values of x where this function or polynomial is equal to 0. So it occurs when x is 1, and it happens again when x is 7. On top of those, we put the funny v symbol, and we put 0 inside them. That means that the value of this polynomial equals 0 when x is 1 or when x is 7. And let's put down our other observations. Below the first 0, our result was positive. Between the two zeros, our result was negative. And beyond the second 0, our result was positive. And that is our conclusion for our analysis of this polynomial. So, what do you think is the most efficient way of analyzing a second-degree polynomial? If you guessed that the most efficient way is to first find the zeros and then test below, between, and then above the zeros, then you're right. Let's get that procedure down. Got it? Good. Let's try one more time to see it in action. Why don't you put example, please? Suppose I ask you this. Analyze the sign of, let's give you another polynomial. How about f of x equal to x squared plus x minus 6. Alright, so first subtitle should be finding the zeros. Okay, now this is a second degree trinomial, so the first technique I'm going to use is product sum. And sure enough, product sum works very, very nicely. So, when will x squared plus x minus 6 equal 0? Under the product sum technique, you should find that the two factors are x plus 3 and x minus 2, thereby making our two solutions minus 3 and positive 2. So we know that the zeros will occur from minus 3 and 2. The big question is, what's going to happen before minus 3? What's going to happen between minus 3 and 2? And what's going to happen beyond 2? Well, let's test it. So, next subtitle, test below minus 3. So, pick any number that's less than minus 3. How about minus 4? Could be anything. So, what is the value of f when x is minus 4? Well, I punched it all into my calculator, and I got a positive result. Okay, interesting. Well, let's see what happens between minus 3 and 2. So, second subtitle, test between minus 3 and 2. Again, pick any random number. Let's say, how about 1? So what is the value of f when x is 1? Well, I punched it into my calculator, and I got a negative answer. Oh, interesting. Alright, and one more test to do. What's going to happen to this polynomial for a value of x that's beyond the second 0? So let's put our subtitle. Test above 2. Alright, so again, pick any random value. How about 3? So what is the value of f when x is 3? And I'm pretty sure I did it correctly. I got a positive value again. Interesting. So, I think we have enough information to form our conclusion. Therefore, the sign of f of x is the following. I'm going to draw my number line. I'm going to put the two zeros down so it occurs at -3 and at 2. I'm going to draw the funny V shape. Fill it in with 0 and 0. And let's see what our test reveals. For any value of x that's less than -3, the result is going to be positive. For our second test, anything between -3 and 2 is going to give you a negative number. Negative. And for anything beyond the second x-intercept, it's going to be positive. There's our conclusion. Alright, I think it's time for you guys to try one on your own. So, put example. I want you to try this one. Analyze the sign of the following polynomial. Let's call it p of x again. Alright, I want you to analyze 2x squared minus 5x plus 3. Go ahead, pause the video and give it a shot. Alright, let's see how you guys did. So first things first, I'm going to find out when this polynomial equals 0. So my subtitle, find zeros. It's a second degree trinomial, so I'm definitely going to use product sum. Alright, so using my product sum technique, I believe that my combination of two numbers are -2 and -3. So it's going to end up like this. 2x squared minus 2x minus 3x plus 3 equals 0. Let's continue with our grouping technique. So I have 2x, x minus 1, second subgroup minus 3, x minus 1 equals 0. And let's finish it off with our common factor technique. X minus 1 and the leftovers 2x minus 3 equals 0. And solving for each bracket, we should find that one of the solutions is x equals 1 and the other solution should be x equals 1.5. So, those are the two zeros. Now let's see what happens below, between, and above those two zeros. So, subtitle, test below 1. So I'm going to pick, how about 0? So what is the value of this polynomial when x is 0? I'm pretty sure I did it correctly. It gives me a positive result. Okay, let's see what happens between the two zeros. So test between 1 and 1.5. Okay, so I'm going to pick, how about, for argument's sake, 1.1. And I believe that, calculating it correctly, it should give me negative 0.08. Feel free to correct me if I'm wrong. And let's test above 1.5. Alright, so for argument's sake, let's see what the value of p will be when x is 2. I believe I did calculate correctly. It gave me a positive result. So, I believe I have more than enough information to form my conclusion. Therefore, the sign of p of x, I'm going to draw my number line, put both of my solutions down when it equals 0, put the funny V symbol, fill it in with a 0. And let's put the results of our testing. Anything less than 1 will give us a y value that is positive. Anything that is between 1 and 1.5 will give us a value that is negative. And anything that's beyond 1.5 will give us a value that is positive. So, how'd you guys do? Excellent. Alright, I would like you to try just one more, so please bear with me. This is an interesting one. So please put example. I want you to analyze the sign of this one. Let's call it, how about t of x? I want it to be x squared minus 6x plus 9. I want you to pause the video and give it a shot now. Alright, let's see how you guys did. So first things first, I'm going to find the zeros. So again, I'm going to use product sum, and it turns out that product sum works very nicely. It gives me x minus 3 and another x minus 3. And therefore, it basically just gives one solution for x. X equals 3. Interesting. This polynomial, even though it's second degree, only has one solution for x. So, all we have to do is test below and test above this single solution. So, subtitle, test below 3. So, let's plug in, how about x is 2? So calculate the value of t when x is 2. And if I did it correctly, it gave me a positive result. Interesting. Now, let's test above 3. So let's plug in, how about x being 4? Well, if I did it correctly, I believe it gives me positive 1. So, let's state our conclusion. Therefore, the sign of t of x is the following. Draw your number line, put down the solution for x, put the strange v symbol, and put the 0. And what happens during the testing? Well, below 3, we know it's positive, and above 3, it's also positive. Interesting. What does this mean about the polynomial? Well, you'll find out later.